So for this problem, to evaluate the limits of indeterminate form, then from this given, so using the direct substitution, so as x approaches to positive 16, so for the square root of 16, this is equal to 4, and 4 minus 4, this one is 0, then over. So x is 16 minus 16. This one is also equal to 0. So the limit becomes indeterminate using the direct substitution. So therefore, we cannot solve this limit using direct substitution. Then in this case, to evaluate this limit, so since the given contains a radical, so we're going to use the conjugate method. So in conjugate method, we just need to multiply the area that contains a radical by its conjugate. So since from this given, the area that contains a radical is the numerator, so we need to multiply this numerator by its conjugate. And the conjugate is just the opposite sign. So times square root of x. So since this one is negative, so the opposite sign, and that's the conjugate. So this becomes plus, then 4. Then also this denominator multiplied by this the same value. So times square root of x plus 4. Then to simplify, so since we multiply the numerator by its conjugate, so to simplify, so just cancel this radical. So this becomes x, then this one is always minus. Then take the square of the second term. So the square of 4, this one is 16. Then over, for this denominator, so just copy. So over x minus 16, then times. So just copy square root of x plus 4. Then again, as x approaches to positive 16, then this time we need to cancel this x minus 16 and x minus 16. So this is now the new equation. So the limit in the numerator, so there is 1, then over the denominator, so we have the square root of x, then plus 4. So as x approaches to positive 16, so to evaluate now this limit, so just substitute this value to x. So this becomes 1, then over the square root of 16 plus 4, or this is equal to 1, then over the square root of 16 is 4 plus 4. So the limit is equal to 1 over 8. Then for this given, so again using the conjugate method, so we need to multiply the area that contains a radical by its conjugate. So multiply this denominator by the conjugate. So this is square root of x plus 2. And again, since this one is minus, so the conjugate is plus, then 3. Then also the numerator, the same this value. So this is square root of x plus 2, then plus 3. Then to simplify, so we have the limit. So in this case, since we multiply this denominator by its conjugate, so to simplify, so again, cancel this radical. So this becomes x plus 2. Then this one is always minus the square of the second term. So we have 3 squared. This is 9. So this is now the denominator. Then in the numerator, so just copy the given. So this is x minus 7, then times. So the square root of x plus 2, then plus 3. So as x approaches to positive 7, then to simplify, so we have the limit. So again, just copy the numerator. So x minus 7, then times the square root of x plus 2, then plus 3, then over this x, and this positive 2 minus 9. So this is negative 7. Then as x approaches to positive 7, then observe that we can cancel this x minus 7 and x minus 7. So we have now the limit of square root of x plus 2 plus 3. Now observe that the denominator is equal to 1, or you can omit this denominator 1. So as x approaches to positive 7, then we can substitute now this value to x. So we have now the square root of 7 plus 2 plus 3. So again, we can omit this denominator 1. So this becomes the square root of 9 plus 3. Or this is 3 for the square root of 9 plus 3. So the limit is equal to positive 6.